Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you how you can solve the problems related to the limits theorem. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the playlist of the IIT Jam solution. In this playlist you can see the various lectures related to the IIT Jam mathematics and statistics available with the help of the shortcut tweaks. Kindly follow and subscribe my YouTube channel for more updated videos. We will cover all these topics in this lecture, but the first question arises is how you can identify under what conditions in your examination you can apply these theorems. First of all, whenever you will see the problems related to the exercise are the sequences of the IID or are the sequences of the independent random variable, then you can apply either of these inequality. I will tell you firstly under what case you can apply the center limit theorems. The center limit theorem is applied when it is given that you have to find the limit of something as n approaches infinity. Then your target is to write in terms of z. On the other hand, whenever there is a statement, when you can apply this weak law of the large number, whenever there is a question related to finding the convergence in probability, fine, plus whenever the sequences are said to be IID, then you can apply the weak law of the large number. For example, you can see this the sequences of the IID and they are talking about the convergence in probability. Then the answer of this is expected value of whatever the term written after this summation sign. The answer of this problem is here. On the other hand, if instead of this IID, it is only given as independent, then how you can find the result? Then you have to apply the center limit theorem. Another inequalities are my Chebyshev inequality, Markov and the Jensen inequality. Jensen inequality is used whenever you are trying to find the bound on the expected mean. However, Markov inequality is used whenever you are trying to find the bound on the probability, and Chebyshev inequality is also used whenever you are trying to find the bound on the probability. But the difference between both of them is Markov inequality is applicable only when variance is not known to you. However, in the case of the Chebyshev inequality, both the mean and the variances are known to you. Then you can apply the Chebyshev inequality, otherwise you can apply the Markov inequality. And the result which we have used for the Chebyshev inequality is here. Another thing is whenever you are talking about this modular sign, then always apply the Chebyshev inequality if the variance is known to you. As I told you, the Markov inequality gives the bound for the probability, while the Chebyshev inequality gives the lower and upper bounds for the probability. I hope you can like and subscribe my YouTube channel. If you are new to my YouTube video, you can scan and join my WhatsApp group. But make sure, student, this group is only for the IIT Jam students, not for the GATE or CSR net. Now let's start with the first question. Before that, I hope you can like and comment on this video as well. What is given to you? Xi's are my exponential distribution and they are my IID. Your target, that means your target is to write Sn in terms of this, where mu is the mean of the Sn. Can you find the sum of this? If Xi follows the exponential, the sum will follows the gamma distribution. Fine. So that means summation of the Xi means Sn will follows gamma distribution of n comma 1. Once we know the Sn follows, can you find the expected mean? Expected mean is n over 1 and the variance of the expected mean is n over 1 square. Always remember, if x follows the gamma distribution a comma b, then what is the expected value? Expected value is a over b and the variance of the x is my a over b square. For more detail about such kind of the shortcut tricks, you must watch my this lecture of the univariate distribution. Now your target is to find the probability Sn greater than equal to n. Now your target is to write in terms of what is the mean of the Sn. So I can subtract minus n on the both side, divided by standard deviation, that is n divided by n. So what is the answer of this? This is z, which is greater than 0. What is the z greater than 0? It is always half is my right answer. You can see, once you can understand this trick, you can get your answer within the 2 lines. Look at the second one. Again, they are the sequences of the IID. So variance of xi is given to you 1. What is the mean? Mean is not given to you, so I can apply say mu. Fine. So I can take on this quantity is my y, x1 minus x2 plus x of 2n minus 1, x of 2n. So can you find the value of the mu y? Because they are my IID, so this has a mu minus mu 0. Can you find the variance of the y? This is a 1, this is also 1, up to, because they are independent and identical, so the total is my 2n. So my given expression is y divided by root n is less than equal to x. Your target is to write in terms of, fine, what is the mu? Mu is my 0, sigma is my root of 2n. Now clearly say I have to, what is that? Root of 2 is already, root of n is already given. I can multiply by root 2 this case. So what is given to you? This is a z, which is less than equal to x by root 2. That is my CDF of x by root 2 is the right answer of this problem. Whenever there is a problem of the limit n approaches infinity, always apply the center limit theorem, and target is to write this method. Again, xi follows my uniform distribution and they are given to you IID. Can you find the mean of the xi? By using the mean of this a plus b over 2, and the variance of the xi is b minus a whole square divided by 12. Then y. Can you find the mean of the y? Because they are my IID, so it is my n over 2. Variance of the y is n over 12. So your target is to write in this form. Fine. So now I can say probability of yn. I can subtract the mu, that is n by 2 on the both side. It is my root n over 12. Now you can divide it both side by variance or standard deviation. You will get. So what is this number? Is a z is less than 1. Z less than 1 means CDF of 1. It is given to you as 0.8413 in your examination. Look at this another one. Xi's are my IID with the mean 2, variance 4. Which of the following statement is or are correct? Very simple, very simple. Look at the first part. I will tell you a 2 different method. What is the meaning of the xn bar? This is my sample mean. Fine. And remember student, these are my population means and the population variance. Why? Because the sequences are my infinite. Fine. And we all know sample mean is always unbiased estimator. Fine. So what does it mean? Xn bar will converge to the E of xi. Fine. And what is the mean of the xi is 2. So that means right answer is fine. Fine. Or how you can write the xn bar? 1 over n summation of the xi, and they are given to you as IID, plus they are talking about the convergence in the probability. So by the weak law of the large number, this will converge to the E of xi, which is given as a 2. So the first answer is correct. Look at the second option. Again, they are IID. They are talking about the convergence in the probability. So the second part is convergence to the E of xi square. And how you can find the expected value of square? We can use the concept of the variance plus expected value of the square. So what is the answer of this? Variance is my 4. This is 4, which is come to be 8. But this is my 4. Second option is cancelled. Look at the third option. Now they are not talking about the convergence in the probability. That is a distribution. Distribution means as n approaches infinity. So we can apply the center limit theorem. What is this follows? This always follows or with the mean mu sigma square over n. So I can substitute the value. Population mean is 2. Sigma square is my 4 divided by n. So can you write in terms of the z minus mean divided by 2 over root n. This will follows my normal distribution 0, 1. And you can see this is the same value which I have given to you. And yes, it follows the normal distribution. Look at the last case. What is given to you this inside part? This is my, because divided by the n minus 1, that's the degree of freedom. So this is my sample variance. And we all know the sample variance is again unbiased estimator of the population variance. So that means expected value of the sample variance is equal to the variance of the population, and the variance of the population is my 4. Yes, this option is also correct. A, C, D are my correct answer of this problem. Dear student, don't forget to like and subscribe my YouTube channel. Xi's are my IID and they are talking about the convergence in probability. So by the weak law of the large numbers, we can say this number will converges to the E of x square. Fine. How you can find the E of x square? I can use that definition of the variance, which is nothing as, so what is the variance? 1. Mean is my 0. Answer is 1 is my correct answer. You can see within the couple of seconds you can get your answer if you are trying to watch this lecture very seriously. Okay, look at this one. Xi's are my IID. And what is that? This is the exponential distribution. But instead of the x, this is my x minus 1 will follows the exponential distribution with the parameter half. Fine. And again, because we need x minus 1, I consider this same number is h. So that means h follows exponential distribution half. Your yn is defined as 1 over n of h square. Now if you look at that, if the limit as n approaches infinity is my 0, what does the meaning of this case? That means this k will converges to the expected mean of the yn. Fine. Now can you find the expected mean of the yn, which is nothing but 1 over n expected mean of the h square. Fine. And what is the mean of the, now from this case, can you find the mean of the h? It is 1 over lambda, because if you know, if x follows the exponential distribution with the parameter a, what is the mean of the x? 1 over a. What is the variance of the x is? 1 over a square. So the mean is my 2. Variance of the h is my 4. So can you find the E of h square? This is variance plus mean square. So 4 plus 4 is 8. So that number is 1 over n. 8 into n, because they are my IID. So the answer is 8 is my correct answer of this problem. Very simple. Just try to analyze the distribution. That's why I'm asking you watch this lecture. Very important for you. Watch this univariate distribution lecture. Okay, what is given to you? Again, they are the sequence of the IID and limit n approaches infinity. That means center limit theorem. Your target is to find the mean and the variance of the Sn. Can you identify which distribution is there? It's a gamma distribution with the 3, 2. Fine. The sum of the gamma distribution is again a gamma distribution, but the first parameter is 3 into n of 2. That means Sn follows the gamma distribution with the parameter 3n, 2. Now can you find the mean of the Sn? Mean of the Sn is a over b, and variance of the Sn is a over b square. So 3n over 4. Now you can write this quantity in terms of Z. Fine. Mu is the mean of the Sn. So you can see I can subtract mean 3n by 2 on the both side. 3n over 2 on the both side. The left hand side is only root 3 into n. I can divide it both side by standard deviation. So that's root 3 root n over 2. This is root 3 root n over 2. The left hand side becomes my z. This term is my 2. So the right answer of this case is phi of 2. And phi of 2 is given to you in the examination as 0.9772 is the right answer. Always get your answer within the 2-3 lines once you are able to identify the univariate distribution functions. Okay, xi's are the sequences of the IID. Again, which distribution is there? Again, it follows the gamma distribution. Power is 2, exponential is my 1. Fine. That means a continuous distribution. So I need a summation of the xi's. Summation of the xi's again follows the gamma distribution with the parameter 2n, 1. Fine. Then, first of all, it is quite obvious because we all know probability at a single point is 0 if x is my continuous random variable. Fine. Probability at a single point is always 0 whenever x is my continuous random variable, and the gamma distribution is always my continuous random variable. So x bar is also my continuous random variable. So probability at the single point is 0. So the right answer is directly you can say it's my 0. Xn is the sequence of the again IID with the probability mass function. That means this is my discrete case. So I can write the table. When x is 4, answer is 1 by 4 and it's a 3 by 4. Xn bar is my given to be this. Again, n approaches infinity. Your target is to find the center limit theorem. That means firstly I can find the mean. Can you find the mean of this x? X into px. So that will be 4 over 4 plus 8, 3, 24 over 4. So 28 over 4 is my 7. Can you find the mean of the x bar? Because they are my IID, so all are my same. So this number is 7. 7 into n is, so that number is my 7. That means this x bar, the mean, if you want to subtract as a mean, it must be 7. And the probability is my 1. What does the meaning of the probability 1? That means xn bar will converges to the, fine, because xn bar I can written like, so this is my 7 and clearly say that lower and upper limits are lies between the 7. Only the D option satisfied. 3 and 1.4.1. 7 does not lies in between them. So the right answer is only D is the correct answer. Okay, look at this another one. Now in this case they are only talking about the independent, not as the identically. Can you identify the distribution again? Again, it is a gamma distribution with the parameter n over 2 and exponential part is my half. Fine. Now this is my xn. Then your target is to write in terms of the z. So xn minus mean divided by 1 over 2 under root. Fine. So I can substitute the value here. So this is the probability. I can subtract n by 2. Fine. So it will be xn minus n over 2, which is greater than, if I subtract them, it is again n by 4 plus I can subtract n by 2. So xn minus n over 2, which is greater than 2 into 2n minus n over 2. Fine. I can divide it by 1 by root 2 on the both side. So this number will be my z. 1 by root 2 is upside, is a 2. Fine. Plus this is my z. I can divide it by root 2. So it is my 2 into 2 is 4 root n minus n over 2. Is it fine? Now, how you can how you can solve this expression as limit n approaches infinity. Now, once you will think about how you can solve this part. Oh, this is, sorry, firstly find the mean. What is the mean of the xn? It's a gamma distribution, so a over b, that is a n. What is the variance of the xn? A over b square, so it is my 2n. Oh, sorry, it is not a n by 2, it is not here. What is the mean is? Mean of the xn, so it is a n and it is my root of 2n. Now we can write in this quantity. I can subtract the n firstly, so it is xn minus n, which is greater than minus n over 4 plus probability xn minus n, then it is greater than of 2 under root of 2n. Then I can divide it both sides by n root 2 into n, root 2 of n, this is root 2 of n, this is root 2 of n. That this left hand side is my z is greater than minus root n over 4 times root 2 plus probability z is greater than 2. Now once you will take the limit as n approaches infinity, this number will be my greater than of minus infinity and this number is my greater than 2. Now your targets to write in terms of the CDF, and you can see if this is my normal distribution, what is the probability which is greater than of minus infinity? Answer is 1, and you can write this quantity is 1 minus, fine, and this number is my phi of 2. 2 minus phi of 2 is the 2 minus 5 over 2 is the right answer. Always remember you have to write the mean of this. What is the gamma distribution mean? Variance of 2n. Fine. Again, I recommended you watch this univariate distribution lecture very deeply. Xi's are my sequences of the IID. With the mean is given to you, variance, then the approximation distribution converges to the large. Very simple. I can consider this is say my yi. 2i minus, fine. Can you find the mean of the y? Because they are my IID, so each has the same mean. So 1 minus 1, 0. Can you find the variance of the y? 1 plus 1, because the variance is my 1. 1 plus 1 is my 2. Fine. So therefore, if I consider this is say my h is 1 over root 2 summation of y. Fine. Now your target is to find the mean of the y and the variance of the y. So what is the mean of the h? Mean of the h and the variance of the h. 1 over root n into mean is my 0. So the mean is my 0. Fine. What is the variance of the h? It is 1 over n summation variance of the y. Variance of the y is my 2. So the answer is 2n over n, that is my 2. So this portion implies it follows the normal distribution with the mean 2, variance is mean is 0, variance is 2 is the right answer. Because whenever they are talking about the large n, that means n approaches infinity. So we can apply the center limit theorem directly. Okay, again these are my IIDs. Fine. U and V are given to you. Now it's a modular sign. So once is a modular sign, you have to apply the Chebyshev inequality, but make sure the Chebyshev inequality, you can apply the Chebyshev inequality. Fine. So firstly, this is U. U is my summation of the xi. What is xi? Xi's are my either 0 or 1. This is 1 over 4. This is 3 over 4. Can you find the mean of the xi? It just like say xi follows the Bernoulli distribution. Fine. So the mean is p and the variance is p into q, or you can find as a expected square and so on. Fine. Can you find the mean of the un? What is the mean of the un? Because they are the IID, so it is 3 over 4. Variance of the un, it is 1 over n square into variance of this. So 1 n will be cancelled out. 3 over 16 into n. Now you can see this is the mean. Fine. So probability x minus mu is less than of a. By using the Chebyshev inequality, it is 1 minus variance of x divided by a square. But make sure mu is the mean of the x. So is the 3 by 4 is the mean of the un? Yes. So I can apply directly. This is 1 minus variance of the x's, because x is my un. 3 over 16 into n square. So n square is my 100. Fine, 100 square. So as limit n approaches infinity, this number is my greater than equal to 1, but probability can never be greater than equal to 1. So the answer is 1. So yes, the first option is correct option. Now look at the second option. Either you can see these are the complement to each other. If the less than is my 1, greater than will be 0. Or you can apply the second kind of the inequality, that is a Chebyshev inequality again. If this number is my greater than, then the answer is variance of x divided by a square. So in that case, it is my 3 over 16n into, so clearly say this number is my 0, but it can never be 0, or it can never be negative. So the answer is 0. So the A and B are the correct options. Now look at the third option. Again, it's a un. Fine. But right now, it's not a modular sign. It is not a modular sign. That means Chebyshev inequality is not applicable. But limit n approaches infinity, we can apply the center limit theorem. So my target is un minus mean divided by standard deviation. So it's a root 3 over 4 root n. So I can write this in terms of root n is here. Find un minus 3 over 4 divided by root 3 over 4. Fine. So that means I can divide it both sides by root 3 over 4, root 3 over 4. So the left hand side is my z and the right hand side is 4 over root 3, which is equal to phi of 4 by root 3. But he said a phi of 2. So C option is cancelled. Fine. Now look at the last option. Now they are talking about the Vn. Vn is 1 minus x. Firstly, x is my here. What is my 1 minus xi? 1, 0. Probabilities remain same. Fine. So what is the mean of, if I consider this quantity is my hi? So what is the mean of hi? This is my 1 over 4. Variance of hi is 3 over, because again it follows my Bernoulli distribution. Fine. Now once you know what is the Vn, Vn is 1 over n h square. Can you find the mean of Vn? Because it's IID, so the mean is again my, is a how you can find the mean? This is hi is a h, how you can find the mean of this number? So yes, you can simply write as a mean because they are the IID. So it's a 1 over 4, n will be cancelled out. So it is my 1 over 4n, and the variance of the Vn is 3 over 16 into n. Fine, because it's n square. Right, again in terms of the, because it's a limit, we can apply the center limit theorem. Root 3 over 4 n I can written in the numerator. Now you can see I can divide it both sides by root 3 by 4 n. The last part becomes z is less than equal to, what is that? This is nothing but phi of 4 by root 3. So yes, this option is correct. So correct options are A, B and D are my correct answers. Okay, xi's are my IID given to you. Which distribution is here? 0 to 1. So x follows uniform distribution of 0, 1. Fine. We need a log of xi's. What is the minus log of xi's? Follows exponential distribution 1. Fine. I need the summation minus ln of x will follows the gamma distribution of gamma distribution of n comma 1. Fine. So I can consider this, say, y. Y is my minus summation over n. Fine. So my target is to find y which is less than equal to 1 plus here. As the limit n approaches infinity, I can apply the center limit theorem. So you can convert into the z. What is the mean of the y? So mean of the y is 1 over n. What is the mean of this quantity? It's a gamma distribution. Mean is my n over 1. That is 1. What is the variance of the y? It is 1 over n square. Variance of the gamma distribution, that is n over 1 square. It is 1 over n. So I can write this number is y minus mean. It is 1 over root n. Fine. I can divide it by under root of variance, under root of variance. So you can see the left hand side is my z, right hand side is my 1. So this part is phi of 1. So B is my correct answer. Always remember your target whenever is a limit n approaches infinity, write in the terms of z. Okay. Xi's are the sequences of the IID, is a normal distributions, summation of the xi4. Fine. So that means your target, if I consider, say, firstly h is my x4. Fine. Or h is my this number. So your target is to find the mean of the h, variance of the h. Fine. I think it's a very simple. Can you find the mean of the x4 and the variance of the x4? That's the only target of yours. Fine. Now because they are my IID and follows the normal distribution, we all knows how you can find the mean expected value of the e raised to power 2n. 1, 3, 5 up to 2n minus 1 sigma of 2n. Fine. So now how you can e of x4? So that means n is my 2. Fine. So if n is 2, what is the value of the x raised to power 4? 4 minus 1, 3. So 3 into, sorry, it's a sigma square. Fine. So it is my 3 into sigma square. Sigma square is 1. So that number is my 3. It is my sigma raised to power n. Fine. So e of this part is my 3. How you can find the variance? I need to find the expected value of the 8 minus expected value of the 4 square. So can you find the expected value of the 8? So for the 8, n will be my 4. If n is my 4, 4 to your 8 minus 1, 7. So that means 1, 3, 5, 7. Sigma of 4. So 1 is a 35. Is a 21, 105. Sigma 4. Sigma square is my 1. So that is my 105. So this part is my 105 minus x whole square, that is my 9. So if you subtract them, it's my 96. Fine. Now that's over because they are my IID. So your what is the mean of the h? Mean of the h is again 3. Fine. Sorry, 3 of n, and the variance of the h is, variance of this is 96 n. So you can write h in terms of the minus 3n divided by 96n. H is my summation of the x square. Now you can see it's a 96, but I have a 32. So I can multiply this number by root 3. I can multiply this number by root 3. Then it's my 96. So the left hand side becomes z. The right hand side becomes root of 2. How you can write this number is phi of 2 is my correct answer. Okay, look at this one. It is my IID with the common distribution. The probability is my 1. What does it mean? That means theta is converges to the probability of expected value of xi's. Fine. So now your target is to find the value of theta. So can you find the mean of the x? How you can find? It's a continuous distribution. X into fx. Domain is 1 to infinity. Now you can integrate them. It is x square. So what is the integration of the x square? Minus 1 over x from 1 to infinity. 1 will be 0, 1 will be here. So 2. So the answer is my 2 is the correct answer of this problem. B is my correct answer. Okay, you can see this is the 2023 is a sequence of only independent random variables such that xi's is my I and 2i. Probability is 1 over 4. Probability is 3 over 4. So can you find the mean of xi? Mean is my I over 4. 6i over 4. That is my 7i over 4. Because I need to calculate the variance, so I can find the firstly e of xi square is I square by 4. I is not a iota. I can be any number. So I square by 4 plus 4i square into 3 by 4. So that will be 4 is the LCM. 12 plus 1, 13 I square divided by 4. So can you calculate the variance? Variance is 13 I square by 4 minus 7 into 7, 49 I square over 16. So 52 minus 49. 52 minus 49 is 3 I square over 16. Fine. Now your target is to find the xi over I. If I consider h is my xi over I, can you find the mean of the h? So 1 over I is outside, so it is my 7 over 4. Can you find the variance of the h? Variance of the h is I square will be cancelled out. It's a 3 over 60. Fine. Now you can see you have to find in terms of z. Yes, in terms of the z. So summation of xi divided by, so this is my h. Fine. So can you find the mean of this number? The mean will be my 7 over 4 into n, or I can write this number is mean is my 7n over 4. This is my mean. Can you find the variance of this? Because they are all are my independent, so it's a 7n over 3n over 60. Now you can write in terms of the z. It's a summation h minus 7n over 4 divided by root 3 root n over 4. Fine. Now you can simplify this. I can write this part is 4 over root 3 root n summation of the h. H is my xi over I minus 4 and 4 will be cancelled out. It's a 7 over root 3 into root n. Fine. So if you compare them, what is my C1? C1 is 4 over root 3. C2 will be minus 7 over root 3. Fine. Now that's over. You can substitute this value. Answer is root 3. 3 times C1, 12 minus 7 over root 3. Root 3 will be cancelled. 7, 12 minus 7. 4 is my correct answer. 12 minus 5. Fine. It's a 12 minus 7 is 5 is the correct answer of this problem. Whenever there is a question related to the n approaches infinity, your target is always in terms of the center limit theorem. Okay, look at this another one. Again, they are the IIDs, but you can see it's a modular sign. That means we have to apply the Chebyshev inequality. So firstly, you can write is IID 0, 1, 2. Probabilities are my same. Fine. Can you find the mean? Or you can say this is my uniform discrete distribution. And if you know the uniform discrete distribution, what is the mean? N plus 1 over 2. Fine. And the variance is n square minus 1 over 12. Either you can use this way. If you use this one, what is the mean of the x will be, n is my 2. So 2 plus 1 is a 3 over 2. Variance of the x will be 2 square, that's a 4 minus 1. 3 over 12 is 1 over 4. Otherwise, you can find the mean corresponding to them. X into px. Fine. So 0, 1 over 3, 2 over 3. So 1 over 3, 2 over 3. So that will be 3 over 3 is 1. So no, where is the error? Did I mistake somewhere? Mean is x into p. This formula is okay. We can I will check it. What is the formula for this case? But okay, we can find the variance. So for the variance, I need to firstly find the e of x square. So that will be 0. It is 1 over 3 plus 4 over 3. That is my 5 over 3. So variance of the x is 5 over 3 minus 1. So 2 over 3. So I need to check this formula firstly. Fine. I need to check this formula. Anyhow, this is the mean, this is the variance. Fine. Now, firstly case for the Sn. What is the mean of the Sn? Mean of the Sn is, because they are the IID, so it's a n times mean of the is a 1. What is the variance of the Sn? 1 over n square into the variance of the x. So it's a 2 over 3 into n. Fine. So I can write somewhere here the mean of the x is 1. Variance of the x is 2 over 3. Now, you can see this is not, you can't apply directly this result. This less than of a, which is greater than equal to 1 minus variance of x over a square. You can't apply them. Why? Because in this case, mu is the mean of the x. But you can see here, 1 is not, half is not the mean of the s. So firstly, I can write this alpha. I can open this bracket. 3 by 4 is less than Sn minus half is less than. Fine. Now you can see it is free from the modular sign. So I can apply the center limit theorem. Fine. Now for this case, I need to write as Sn minus mean. So I can subtract minus half on the both side. Fine. Then it is 3 by 4 minus half. Fine. The left hand side is my negative. So it's a 6 minus 5 over 4 is less than of something. It is my 1 over 4. Then I can divide it both side by, in terms of the z, it's a root of 2 over 3. N will be my upside. Similarly for this case, 2 over 3, n is my upside. And once you will take as n approaches infinity, the left limit is my minus infinity to plus infinity. What is the answer of this case? Is a 1. So alpha 1 is my 1. Fine. Similarly, we can look about the second case. Again, we can't apply the center limit theorem because 1 over 3 is not the mean of the s. Again, I can open this bracket. It's a minus 1. Sn minus 1 over 3. Fine. Because Sn has a mean 1. So I can subtract 2 by 3. So I can subtract minus 2 by 3 on the each side. It is minus 5 over 3. Sn minus 1 and 1 over 3. In order to write in terms of the z, I have to divide it by the root of the variance. Fine. So I can divide root 2 over 3. N is my upside. This is my z. 1 over 3. Root 2 over 3. N is my upside. Again, by taking the n approaches infinity, this is minus infinity. This is plus infinity. The answer is again 1. Fine. Now, look at the third case, which is defined as a Tn. So your target is to find firstly the mean of the Tn. How you can find them? Because they are the IID. So which is nothing but E of x square. And what is the mean of the x square? We have computed. Otherwise you can compute from this case. So mean of the x square. So we can see from here is a 2 over 3 plus 1, that is 5 over 3. Can you find the variance of the Tn? Variance of the Tn will be 1 over n square into n times variance of x square. How you can find the variance of the x square? It is 1 over n. It is expected value of the x4 minus expected value of the x square. Fine. It's a 1 over n. How you can find the expected value of the x4? 0. 1 over 3 plus x4 is a 16 over 3 minus expected value of the x square we have computed. So 5 over 3 square. Fine. It's a 17 over 3. 17 into 3. LCM is my 9. So 17 into 3, 51 minus 25. So it is my 26. Fine. Again, you can see the mean of the Tn is not 1 by 3. So I can open this bracket. I can write this case is E of Tn is my 5 over 3. Variance of Tn is 26 over 9n. Now I can open this bracket. Again, we can't apply the Chebyshev inequality. I can open this bracket. Probability minus 3 over 2 minus 1 over 3 plus 3 over 2. Since I need a 5 over 3, I can subtract minus 4 over 3 on the both side. So minus 3 over 2 minus 4 over 3. So 9, 8, 17 over 3. Fine, this is my 5 over 3. And this is 3 over 2 minus 4 over 3. So 9 minus 8, 1 over 6. Then I can divide it both side by under root of 26 by 3 root n. 26 over 3 root n. 26 over 3 root n. This portion becomes my z. This root n in the numerator. And when you take as n approaches infinity, this is my infinity, this is my minus infinity. So the answer is again 1. So this answer is also 1. Similarly, we can apply for the last case. I can subtract, I can write this term is minus half Tn minus 2 over 3 plus half. Then I can write 5 by 3 on the subtract 5 by 3. So this part is my negative of something. Fine. If I subtract minus 5 over 3, fine, it is my minus 1 over 6. It's my negative of something. If you divide it again by root 26 over 3 into n, root 26 over 3 into root n, fine, if you take as n approaches infinity, this limit is minus infinity, this limit is again minus infinity. So what is the answer of this? 0. So alpha 1, alpha 2, alpha 3 are my 1 and alpha 4 is my 0. So what is the right answer of this? 6 is my correct answer of this problem. Okay, look at this another one. Again, they are the sequence of the IID. X follows gamma distribution with the parameter 3, 1. I need the summation of the xi's. Summation of the xi's again follows the gamma distribution with the parameter 3n, 1. I consider this number is my y. Y is my 1 over n. Summation of xi. So can you find the mean of y? So it is a 1 over n. The mean of this quantity, is my 3n. So this is my 3. Variance of the y is 1 over n square. Variance of the gamma distribution, so 3n over 1 square, it is my 3 over n. So I can write this given expression y in terms of the z. So this number is my z is less than equal to x minus mean is 3 divided by root 3 over n. Fine. So I can say this is my CDF. Fine. Now when it will be 0, Once is a CDF, you can see this is the expression of the CDF. I can write this expression is nothing but phi of x minus 3 divided by 3 over n. And we all know the CDF, the last value, first value is 0, the last value is my 1. The first value is 0 when this part is my, you can see also, I can say this is my root n x minus 3 divided by root 3. Fine. Now once you will take as n approaches infinity, this number will be infinity, but depending upon the value of the x, whenever x is my less than 3, this number will be my minus infinity. What is the value of the phi minus infinity? It is my 0. Fine. And when, if I say phi, whenever x is my greater than 3, then this number has a complete 1. Fine. So that means I can write this number is also. So whenever x is 3, this is 0. What is the value of the phi of 0? Phi of 0 is my half. Now you can compare them. So that means beta is my 3, gamma is my 3, k gamma must be 1. So the k must be 1 over 3. Now you can substitute this value. It is 6 plus 9 plus 2. So 6 and 8, 8 plus 9, 17 is my right answer of this problem. Just apply the concept of the CDF. That's a concept is similar. Always write in the terms of the Z and get the right answer. Okay, you can see this is the question related to the 2024. X follows binomial distribution with the n comma 1 over 4. Again, the limit n approaches infinity given, we can apply the center limit theorem. Can you find the mean of the x? Is a n into p. What is the variance of the x? Is a binomial distribution npq. So 3n over 60. Fine. Now you can see what is your z is xn minus mean over variance, under root of variance. So root 3 root n divided by 4. Fine. So now you can see I can firstly write this number is, I can subtract minus n by 4 on the both side. Fine. So if you subtract minus n by 4, this term will be cancelled. Minus root 3 over 8 into root n. This is the first term plus probability. I can subtract minus n over 4. So it is n over 6 minus n over 4. 12 is the LCM. 2n minus 3n. So it's a minus n over 12. xn minus n over 4. Then I can subtract n over 4 on this case. So it is 1 over n over 12. Fine. Now you can divide it by root 3 root n into 4. So this part is my z. This term root 3 root n will be cancelled. 4 in the numerator. It is my minus half plus. You can see about this case when you divide it by root 3 root n. Fine. So 1 root n will be cancelled. It is my minus 4 root n in the numerator, root 3 in the denominator, and 12. This term is my z. This number is my root n in the numerator, 12 root 3 and 4 in the upside. Now once you will take as n approaches infinity, this number is my minus 0.5. This number is my minus infinity. This number is my plus infinity. What is the limit as minus infinity to plus infinity? Answer is 1. And that is the answer of this problem. But in this case, you have to find the exact answer. Now you can see, if you look about this graph, minus 0.5. This is my minus 0.5, which is same as of plus. These both areas are same. Now, what is the given meaning? That means up to this portion is my 0.6915. Can you find this area? It is 1 minus 0.6915. which is same as of this area. So the answer is 1 minus 0.6915 plus 1. So you can subtract them. After subtract them, you will get as 0.3085 plus 1. So 1.3085 is the right answer of this problem. Okay, look at this another. Xi's are the random samples, variances, and so on. Again, Xn, which is nothing but my sample mean, Sn square, which is my sample variance. Fine, because divided by the degree of freedom. And the first target, sample variance, is always unbiased estimator of the population variance. So what is the population variance? Population variance is given as a 1. So Sn square is converges to the 1. Yes, first option is the correct option. Second one, they are talking about the distribution. So we convert into the Z. What is the Xn? It follows my normal distribution with the mean sigma square over n. So what is the mean? Mean is my 0 because they are the random, that means IIDs. Variance is my 1. Now can you write in terms of the Z? Xn minus mean divided by 1 over, it follows normal distribution 0, 1. So you can see which is the same thing. So yes, this option is correct option. Look at the third one. Third one is my sample mean and sample variance, X bar, and we all know the sample mean and the sample variance are always independently distributed. Yes, this option is the correct option. Look at the last option. Because they are the random samples, that means they are the IIDs. Fine. So once they are the IID and they are talking about the convergence in probability. Convergence in probability means you have to apply the weak law of the large number. So that term will converges to the E of xi square. So can you find the value of the E of xi square? Variance plus mean square. Variance is given as a 1 plus 0, which is 1. So this option is cancelled. Only A, B, C are my right answer of this problem. Okay, again they are talking about the random samples. X follows F distribution with a 20,40. Okay, so what is the convergence in the probability? So what is the answer of this? It converges to the 1 over x. And if x follows the, what is the 1 over x? It follows 40,20. Why? Remember always, if x follows the F distribution m, n, 1 over x will follows n, n. So what is that? Can you find the mean of this? So what is the mean of the x? N over n minus 2. Mean of the F distribution. So in this case, mean is my 20 divided by 20 minus 2. So 20 over 18. So 1, 1, 1, 1. So up to the 2 decimal places, 1.11 is the right answer of this problem. Okay, look at this another one. If xi's are the sequences only independent such that x of 2k minus 1, either the 1 minus 1, probability is half and half. Can you find the mean of 2k minus 1? 0. What is the E of x square up to the 2k minus 1? So that will be 1 square 1 plus 1. What is the variance of 2k minus 1? 1. Fine. While the distribution of the x raised to power 2k is 1 over root 2 e raised to power minus root 2 of mod x. Can you identify the distribution function? Yes, it is a Laplace distribution. It is not an exponential because it's a modular sign. What is the Laplace distribution? F of x, which is equal to 1 over 2 into b minus x minus mu over b. If you compare them, you will get the mean is my 0. Fine. If you look at the b will be 1 over root 2. Fine. And you can see 1 over root 2 is satisfied. So therefore, the mean of this is satisfied the x of 2k. The mean of the x of 2k is my mu. Mu, if you compare them, 0. And variance of the x of 2k in case of the Laplace distribution, the answer is 2b square. So what is the b? 1 over root 2. So variance is 1. Fine. So I can summarize this here. This is variance of x 2k is also 1, and the mean of x 2k is my 0. Now that's over. Again, your target is to find the limit as n approaches infinity. So we can apply the center limit theorem. I can simply take y is x1 plus x of 2n. Can you find the mean of the y? x1 up to the 2n minus 1. The answer is 0 and the 2n is also 0. Can you find the variance of the y? Up to the 2n minus 1, the variance is 1. It is also 1. So the 1, 1, 1 up to the 2n. So can you write in terms of the z? Y minus 0 divided by root of 2n. So the answer is, the left hand side is my y. So the answer is z is greater than equal to 1. How you write that? This number is z is greater than equal to 1 is also same as minus 1. That means it is my phi of minus 1 is the right answer of this problem. And you can see this is the simple way you can get all these answer in a simple. I can give you one more example related to the gate. You can see they are my IIDs. Mean is my 4, variance is my 1. Fine. So you can write in the z x minus 4, sorry, this summation of n. Firstly I can take y. This is my y. Fine. Your target is to find the y, mean of the y. Because they are the IIDs, so each has the same mean. So this is my 4n, which is 4. Variance of the y is 1 over n square into 1 into n. So that is 1 over n. So I can write this quantity is y is greater than 4.0006. You can convert into the z. So mean minus divided by 1 over. So now once you will take as n approaches infinity, this number will be, once n approaches infinity, what will happen? As n approaches infinity, the answer is infinity. And what is the probability as z greater than infinity? Is a 0 is my correct answer of this problem. Similarly, if you look at one more example, xi's are my IIDs with the probability. So xi's follows my Bernoulli distributions, then converges almost surely. So that will converges to the expected value of the x k raised power k, where k can be any number. If x follows the Bernoulli, what does the meaning of the xk? It also follows the Bernoulli distribution. Fine. So that means how you can find the, if I consider y is x raised to power k, your target is to find the mean of the y. Fine. So we all know in case of the Bernoulli distribution, the mean is p, variance is p into q. So can you find the e of y? That is the mean. So mean is my p. Answer is A is my correct answer of this problem. Fine. Look at one more example. These are the sequences of the IID. These are the sequences of the IID. Mean are shown. Okay, firstly, your target is to write in this case. Again, can you find the mean of the yn? 1 over n is outside. What is the x1 square? 1, 1, 1, 1. That is the n. So mean is my 1. Can you find the variance of the yn? 1 over n square is outside. This is the variance of the x4, x square. How you can find the variance of the x square? E of x4 minus x square. Fine. What is the E of x4? 3 minus 1. That's a 2. So 2 plus 2 plus 2 up to the n times. So that is a 2 over n. So your z will be yn minus 1 over 2 by n of root. Fine. So I can substitute the value here. So it's a probability. I can subtract minus 1 firstly plus root n over root 3. There is no need to subtract. So I can write this number is 1. Fine. Now I can write this value is root 2 by n. This number is, I can say, root 2 over n plus root 2 over into z. This is root n into root 3. That is my multiply and divide by root is z is less than equal to 1. Fine. So can you find the value of the, I can take z as a common. This will be cancelled out. Root 2 over n plus root 2 over 3, which is less than equal to 1. As n approaches infinity, this term will be 0. So your answer becomes root 2 over z is less than equal to 1. So that means z is less than equal to 3 over, so which is nothing but my 5 of root 3 over 2. So if you compare them, c is my root 3 over 2 and they are talking about the c square. Answer is 1.5 is the right answer of this problem. And you can see that it's a very simple approach. You can get your answers in a very easy manner. Fine. If you want more, the gate 21, again they are the sequence of the IID converges to the 0. So your target is to find the value of this. What is given to you? Xn of alpha is either the 0 or 1. If it is 1, then n of 2 alpha, it is 1 minus n of 2 alpha. Can you find the mean? Fine. And when it will be convergent? It is convergent only because if you look about the series, it is convergent only when 2 alpha is greater than 0 by using the p test. So that means alpha is greater than half, and once alpha is greater than half, the supremum value, infimum value is my 0.5 is the right answer of this problem. So this is the way you can solve all these PY questions in a very simple manner. Look at some more questions. Look at that gate 2024. Again, it's a very simple. They are IID. What is given to you? X minus theta will follows exponential distribution with the parameter 1. Then they are talking about the convergence in the probability. They are given to you IID. So what is the answer of this? It converges to E of xi. So can you find the mean of the xi's? So it will be E of x. What is the mean of the exponential 1? Is a 1. So its answer is theta plus 1. But they are talking about half of this. So this option is cancelled. Which of the following statement is true? Only one cancel, both cancel. Now, what is given to you? X minus theta follows the exponential 1. Then the minimum of the xi's, it again follows the exponential distribution, but the parameter is n into 1. But in this case, x minus theta, that means xi's minus theta. Minimum of this will follows exponential distribution n, or you can say the minimum of xi's minus theta will follows the exponential parameter n. Fine. Now you can see is a limit value. Can you find the expected number of this? What is the mean of this quantity? Mean of this is the minimum of xi, that is the ordered statistics 1. minus theta, which is equal to 1 over n. So can you find this? As n approaches infinity, this part will be 0. So expected mean of the 1 is my theta. And you can see this is my correct. So neither is wrong. Only B option is my correct option of this problem. And you can see it's a GATE 2024 is a very, very simple solution. Look at one more, say GATE 2024 again. Can you identify the distributions? Only they are independent given to you. That means x follows exponential distribution with the parameter 1 over lambda n. This is given to you. Where lambda n is my here. I can write this lambda in terms of is a summation I. So 2 raised to power 10 is outside, is a 1 over 2 raised to power I. Then which of the following statement is or are true? Convergence in the distribution, convergence in the probability to the zero random variable. That's fine, it's very simple. How you can form that? Xn converges to what? Xn converges to the mean. So can you find this limit firstly? Fine. It is 10 minus, it is I varies from 1 over. So this is my GP series. Fine. What is the sum of the GP series? A over 1 minus R. That is my 0. Fine. It's a half. It's a 0. That means Xn converges to a 0 in terms of probability as well as the distribution. So yes and yes. Xn converges to the distribution, fine, but the mean 0. That's wrong. It is converges to the 0 mean. So this option is cancelled. It converges to the mean 10. This option is cancelled. Only A and B are my right answer of this problem. So you can see that all these lectures are totally based on this univariate distribution. You must watch this first lecture and then try to understand the remaining parts. I hope you can like, comment and subscribe my YouTube channel. We will see the second part. If I get the enough likes and good response on this video, I will upload the next part very soon. Till then, you can share this video with your friends. Best of luck, students, and please don't forget to subscribe my YouTube channel. Best of luck, students. Happy learning.